In this video, we're going to be looking at how to find the dimension of some physical quantities. So we have some physical quantities here. We are going to look at their derivation, their analysis, their dimension, and their derived unit. I want you to know that dimension is used to express physical quantity in the base quantity, that is the fundamental quantity, in terms of mass, length, time, and all other fundamental quantities such as current. So our first derivation here is going to be area. So we know that the derivation for area is length times breadth. Okay, so the analysis is going to be length for L. So when writing dimension, use capital letter L times, so whether be it breadth or height will be represented as length. So the dimension is L squared. And you know L stands for length. So since L stands for length, the unit of length is meter. Then this, you're going to put the square, so that's meters squared. So notice that this is written in small letter, but this is written in capital letter. So dimensions are written in capital letter. Volume is going to be length times breadth times height. So the analysis is going to be length L times L for breadth and times L for height. So that will be L cube, and the unit of L is still length, is still meters. So we have cube there. So the unit of volume is meters cube. Then we have density. Density is mass divided by volume. So mass divided by volume, mass is M, capital letter M, and we already know that volume, the dimension of volume is L cube. Okay, so this will be written as M. Now you see this is L cube is dividing M. So when this goes up, this 3 goes up, you have this as L minus 3. Okay, this slash here, the 5 here, when written in index form becomes what? Minus. So the unit of density will be kilogram. That's the unit of mass. Then L is meters. Then we'll have per raised to power minus 2. So that's kilogram per meters cube. Then we'll go to velocity. Velocity is displacement over time. All over time. Okay, so displacement is still length. So this will be L for length, and time is capital letter T. So the dimension is going to be L. Each time you see this slash here, you change it to -1. Minus, so that's LT -1. So the unit of length is meters, and the unit of time is seconds. So we have per seconds. So let's go to acceleration. Acceleration is mass, is velocity divided by time. Okay, velocity divided by time. So we already know the dimension for velocity as LT -1. So I'm going to have LT -1 divided by time is capital letter T. So when this goes up, it becomes L2 -2. So that's LT -2. Okay, so when this goes up and add to this, it becomes -2. So from here, we can get the unit. The unit of L is meters. The unit of T is in seconds. And we have -2. So this is going to be read meters per squared second or per second squared. Force is equal to mass times acceleration. Okay, so mass is M, and we already know the dimension for acceleration, that's times LT -2. So the dimension is going to be M LT minus 2, and the derived unit will be kilogram. Then L is meters, then per second square. But sometimes there are some derived quantities whose units are not expressed as group of symbols. So we can just write it as N, which is Newton. So 1 Newton is the same as 1 kilogram meters per second squared. Then next, we have work on energy. Work is equal to force times distance. So force, we know the dimension of force as M LT minus 2 times distance is L. So the dimension is going to be M. So when you multiply L by L, that will give us L squared. Then we retain our T minus 2. So the derived unit is going to be kilogram meter squared per second squared. Again, like force, this can just be represented as joules. Next is power. Power is work or energy divided by time. So we already know the dimension of energy as M L squared T minus 2 divided by T. So this becomes M L squared. Then you see T squared divided by T. That is minus 1 minus 2. That gives us minus 3. So the unit will be kilogram for mass, L for M for L. Now you put the squared. Then S for time minus 3. So this can just be written as watt or joules per second. Okay. So 1 watt is 1 kilogram meter square per cubic second. Okay. So momentum is mass times velocity. So M is mass and velocity. We know the dimension for velocity as LT minus 1. So we have times LT minus 1. So when we combine this together, it's going to be MLT minus 1, which is kilogram meters per second. It can also be expressed as Newton seconds. Then we have pressure. Pressure is force divided by area. Okay, we know the dimension of force. The dimension of force is MLT minus 2. MLT minus 2 divided by area. The dimension of area is L squared. So we have L squared. So work this out, we are going to have M. So here, this is going to be L raised to power 1. This one will cancel out. This we are left with 1. That's L raised to power minus 1 with T raised to power minus 2. So this is kilogram per meter per second squared, which is the same as 1 Pascal. So these are the dimensions of these various derived quantity. We